In this video, we're going to talk about motion. What is motion? How do we describe if something, is moving, as well as speed and velocity and acceleration and all of that grand stuff. So by the end of this video, you should be able to explain how the motion of an object can be described by its position, its direction, and speed in respect to other objects. So let's get started. So what is motion, and how do we know if something is in motion? Well, motion is if an object's distance is changing from another object. Okay, so for example, if the distance between A and B is changing, then one of them are going to be in motion, either A or B. But just trying to figure out which one's going to be in motion, well, that's why we use this thing called a reference point. So a reference point is a place or an object used for comparison. So for example, if we use A as our reference point and the distance is changing, then it's going to tell us that B is in motion. So let's actually look at an example of this. We've got this lovely bike rider here on Hillburn Drive, just pedaling away, getting in some exercise. And for this example, we are going to use the stop sign as our reference point. So I want you to watch what is happening to the bike rider in comparison to that stop sign. Right? She's moving away. So who's in motion here? The bike rider, right? Her distance is changing from the reference point, making her appear to be in motion. Well, motion is relative. And what do I mean by relative? Relative, if we define it in just its normal Webster dictionary, it's going to tell us that it is considered in relation or proportional to something else. So relative motion is whether or not an object is in motion depends on the reference point you choose. So for example, let's take a ride. Back on Hillburn Drive, this time we are in this nice, lovely little green car, and we're so happy because we're going to school. It's a great day, and I want you to imagine the last time you were in a vehicle, whether that was a bus or a car or some type of, moving motor vehicle. And close your eyes and imagine you sitting there. Okay, now open your eyes. The stuff around you, the dashboard, the steering wheel, the seat in front of you, did that really appear to be moving? No, probably not, right? Unless something was a little wobbly. But it probably didn't appear to move. Now look out the window of your car. All the stuff that you're passing by, does it appear that it is moving? Yeah, if you're going forward, it probably appears that all of it's starting to move behind you. Okay, that's relative motion. The trees appear to be in motion relative to you in the car. So if you were using you in the car as the reference point, well then that tree's distance is changing from you, and it appears that it is in motion. We're going to do a little bit more work with this and kind of talk about this too, because I know it's kind of a difficult thing to process, because technically you're the one moving, but it's all relative. So now that we know if an object is in motion, we need to figure out how fast it's going to, go. So we're going to look at speed. And speed is just basically how far does it go and how long did it take it to get there. So this equation down here is really, really important. Speed equals distance divided by time. So how long did you go and how long did it take you to get there? However, whoops, oh, there goes some emails. So objects it is very rare that they maintain the same speed. If you're in a car, you're going up and down hills, which is affecting your speed. If you're running, you might get tired, and so you're not constantly going. So we use this thing called the average speed. So basically the only difference is you're taking all of your distances divided by all of the different times it took you to get there, and that will give you your average speed. So let's do a quick practice problem. Olympics just ended, so feeling really inspired by Mr. Michael Phelps and his 28 medals. So Michael Phelps swam 200 meters in 100 seconds. How fast is he going? Well, let's look at our distance, 200 meters divided by our time, 100 seconds. So he was going 2 meters per second. Units, units, units. Units are super, 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 super duper important. Okay, do not forget your units. So we know our speed, but what happens if you move to the east or move to the west or go north or go south? Well, that's what we call our velocity. So our velocity is our speed plus our direction, okay? And we'll do a lot of this when we get to weather, okay, when we talk about storms. And you hear this if you watch the news and listen to the weather. You hear this very often. So velocity, speed plus direction equals velocity. A quick example, a storm is traveling east across the USA at 50 miles per hour. Okay, what is our velocity? Our speed, 50 miles per hour, plus a direction, east. So our velocity equals 50 miles per hour east. So one of the terms that you're probably very familiar with, that you've heard very often, is called acceleration. And when our velocity changes, that is when we say something has accelerated. So acceleration is just calculated our final speed minus our initial speed divided by our time. Okay? Just a quick note, when we use our units for acceleration, always use meters divided by seconds squared. So there's a couple ways that we can accelerate, because remember, acceleration is changing our velocity, and velocity is speed plus direction. So the first way that we can accelerate is probably the most common that we hear, and that is to speed up. So if your speed increases, you are accelerating. Now, if your speed decreases, your velocity is still changing, right? You are decelerating, okay? Slowing down, decelerating. The third way is not the most commonly thought of, but it is acceleration because we're changing our velocity, and that is when we change direction. So when you change direction, you're changing velocity, which means that you are accelerating. So let's practice really quick. Here's just a simple simple problem that's going to help us kind of understand acceleration. So as Emma rides her bike, Madame Blueberry, down a hill, she is traveling at 4 meters per second. After 30 seconds, she is at the bottom of the hill, traveling 34 meters per second. What is her acceleration rate? Okay, well, let's do our final speed minus our initial, so 34 meters per second minus 4 meters per second. Okay, what does that give us? 30 meters per second divided by our time, so 30 seconds. So 30 meters per second divided by 30 seconds equals 1 meter per second squared. So if you got that, you got it. Some quick questions I do want to ask you. If you are running around a track at an even, well, not running, let's do, if you are riding a car around a track, so a circular motion, and you're going a constant speed, yet you go into your first turn, are you accelerating? Yes, right? Because we changed our direction. So if we turn to the left, we are changing our direction, which means that we are accelerating. What about when you hit the pedal, the brake pedal? Are you accelerating? Yeah, you're changing your velocity or your speed, which means that you are decelerating. Absolutely. All right, so keep these in mind as we are calculating this and understanding how objects change acceleration rates, how they're changing velocity, because this is really going to come and help you during this unit.